Okay, so today I will show you how to create this 3D looking compass using the Arduino and the OLED display. And as you can see, I'm also using this simple potentiometer to set the heading, the angle of the compass. Obviously for a real project I would use some real sensor, but today it's all about the graphics. So I'm using the Arduino UNO, the 10K potentiometer and this OLED display. It's the SSD1306, that's the driver chip being used inside this display, connected using the I2C connection, so we only need 2 wires for the data and 4 wires in total. And the resolution of the display is 128 by 32 pixels. This is a monochrome display, meaning that it can only display one color, but you can get 3 different versions of this display, being the white, blue and yellow. But I only have white and blue. Before we dive into the project, let me talk about the sponsor of today's video, which is PCBWay. Because if you are making electronics projects, sooner or later you will need PCBs or maybe PCB assembly or even things like 3D printing or CNC machining, and PCBWay offers all of those services, actually even more for a reasonable price. Plus, if you click the link in the description of this video, you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay. So with all that said, let's get started. And similar as with many of my other projects, we will not be starting with the real Arduino, but instead inside Wokwi. Wokwi is a free online Arduino emulator that supports the Arduino UNO, as well as the potentiometer, as well as the SSD1306 OLED display. The only thing to keep in mind is that this display has the resolution of 128 by 64 pixels, and our display only has the half of the resolution, only 128 by 32 pixels, so we should be drawing stuff only on the upper half of the display, otherwise the content will not be visible on our real display. I will not be starting from scratch, but rather from this video titled Image to OLED in 60 seconds. You should definitely watch it if you haven't seen it already, because again it only has 60 seconds, and this is the Wokwi project for this video. It might look complicated, but most of the stuff is just comments and the data for the full screen image being drawn on the display, so if I collapse this part of the code, we are left with just few lines of code. First we include the U8G2 library and the wire library for the I2C communication. Then we set the correct initialization for the used display. We start the communication inside the setup function by calling the begin function. Then inside the loop we clear the buffer, draw the image and send the buffer to the display. This delay here is optional. By the way, if you are not starting from this project and you want to use the U8G2 library, you have to also go to the library manager and make sure to include the library here as well by typing U8G2 and adding this library. In our case, we don't want to draw the image, so I can just comment out this line and delete the image data, and if I restart the simulation, there will be nothing on the display. We want to draw those individual tick marks as lines, and for that we can use the draw line function. So if I open the documentation, there is this example in here, so I can just copy this into clipboard, try to paste it in our code between clearing the buffer and sending the buffer to the display, and if I restart the simulation now there is a line being displayed on the display. We don't want to draw just one line, we want to draw multiple lines, and we want to set the X position based on the compass heading. And same as in my real project, I will be using potentiometer to set the angle value, so I will stop the simulation, click the plus icon and add the potentiometer. I will connect it in a way that the signal will go into one of those analog input pins, for example A0, and then of course ground should go to ground and VCC should go to 5 volts. Now if I select the potentiometer and click the question mark, it will open the documentation, and there is a very simple example of getting the value of the potentiometer. I will copy the pin mode inside our setup function that will set the pin mode of the pin A0 to which we have the potentiometer connected to be the input, and then inside the loop we will be reading the value of the potentiometer using the analog read value, so I'll paste it in here as well, but instead of having the variable called value, I will create a new variable and I will call it with some meaningful name, for example compass degrees. And I will say that the compass degrees equals the analog read of the pin A0, but this goes between values 0 and 1023, and I want the compass degrees to go between 0 and 360 degrees, so I will use the map function to remap this analog value, which originally goes from 0 to 1023, to go between values 0 and 360 degrees. Before drawing the tick marks, let's show the compass degree value on the display, and for that we will be using the drawString function. So if I open the documentation, there is an example of setting the font and drawing the string, so I'll just copy both into our main loop and paste it after drawing the line. For now I want to use some really small font, for example this U8G2 font called 4x6, so for the font I will use U8G2 font 4x6 TR. I believe the R stands for reduced, and I want to draw it somewhere on the bottom of the display. So for example, x0 and y50, and I want to draw the compass degrees, but I cannot just use the compass degrees inside this function because it requires a C-style string. So I need to create a new variable as the array of characters, and let's call this buffer, and for example, use up to 20 different characters. And before drawing the string, we need to convert our compass degrees into our buffer string. I like to use the sprintf function, which is kind of advanced, but it allows a lot of stuff. The first parameter should be our buffer. The next parameter is a string of parameters. I want to convert one integer value, that's the %d, and the variable name is compass degrees. And then inside our drawString function, we will be drawing the content of the buffer. Let's restart the simulation. And there should be a very small number on the bottom of the display that shows the value of the potentiometer, but you see it's updating quite slowly. That's because we've kept this delay in here, which we don't really need, so I can just delete it and restart it again. And now the numbers should be updating much faster, going from 0 all the way up to 360 degrees. We need to decide how many tick marks we want to show for our compass, and if I search for compass on the Google Images, I would like to display those major labels being the north, east, south and west, and those are on 0, 90, 180 and 270 degrees, so every 90 degrees. I would like to also display those minor labels which are on the positions of 45 degree increments, and I would like to probably display some in between tick marks as well. And I think that the simplest solution will be to display the tick mark every 15 degrees, because that will line up nicely with the major labels as well as with the minor labels. Which means that for the 360 circle, we will be drawing 24 tick marks. So let's do that. Inside our main loop, I will create a new for loop for the integer y starting from 0, running the loop while I is smaller than 24 and increasing the y by 1. And what we want to do is to calculate the exposition of those individual tick marks, and for that we need to know a few things, starting with what will actually be the spacing between those tick marks. Again, we have 24 tick marks, and at any time I want to show about half of them, so I will show 12 tick marks. And just because the width of our display is 128 pixels, I think it would make sense to make the spacing between those tick marks to be 10 pixels, so they will span across 120 pixels. Which also means that all the 24 tick marks will span across 240 pixels, and that will actually be the maximum x-offset value for moving the tick marks around. Let's add two more variables. The first will be x position offset, and that will be the x-offset for all the tick marks based on the compass heading. The next value will be x position with offset, and that will be the x position of the actual tick mark. So first of all, we will calculate the x position offset, and of course this will be based on the compass degrees, which goes up to 360 degrees, but we want to only go up to 240 pixels, and I will round it to the integer value. Then inside our for loop, I will calculate the x position with offset as being the I times 10, that's the spacing between those individual items. I want the first tick mark to start in the middle of the display, so it will be 64, that's the middle of the display, plus this spacing. And I will of course add the x position offset as well to this value. So this is the final x position of the tick mark. We just need to draw it using the drawLine function. The x position will be x position with offset, the y position will be 7 for example, the end x position will be again x position with offset, and the end y position might be for example 13. So let's restart the simulation and see what happens. And we indeed see some tick marks, but as I increase the angle of the compass, they are scrolling to the right side and then they simply disappear. To prevent this from happening, we need to wrap those around, meaning that if they reach the maximum value, being the 240 pixels, they should go back to the beginning. And we can do this very easily by applying the modulo function. So the modulo function, which is a percentage sign, will give us the remainder after division. So if I use the modulo by 240, it will wrap around and always go between 0 and 240. So let's restart the simulation now and see what happens. And indeed, now the tick marks are filling the entire screen. But it's hard to tell which is the first tick mark, the second tick mark and so on. So just for debugging purposes, let's show the angle values for those individual tick marks. I will copy the code for drawing the compass degrees into our main loop, keep the same font, but instead of converting the compass degrees, we will convert the value of I times 15, that should give us the angle. The x position of the string will be x position with offset, and the y position could be for example 20. However, even with this small font, it's impossible to squeeze all those digits for those tick marks, so what we can probably do is to draw those labels rotated by using the setFontDirection function. So just paste it before drawing the string, and now it looks much better. I have tweaked the positions of those labels to be closer to the tick marks, and I have also moved the compass degrees to be on the top of the display in the center. I have also realized that I'm calculating the X offset in the wrong way. It should of course be degrees divided by 360 multiplied by 240. But even with this change, this number on top, the compass degrees, is not lining up properly with those numbers on the tick marks. You can see that for the value of 360, it shows 0, which means that we need to calculate the X offset in a slightly different way. Instead of using the compass degrees, we should say 360 minus compass degrees. And as I restart the simulation now, both values should be now aligned. So for example, when the compass degrees is showing 90, it's lined up with the 90 tick mark as well. So we can now move the tick marks and show the correct value. Let's address the elephant in the room, and that's the actual visual appearance of those tick marks, because while we have tick marks and we can move those around, they are just flat 2D boring tick marks. There is nothing 3D about those, so let's just fix that. And we can do this in a few different ways. I think that the easiest solution is to change the spacing of those tick marks, meaning if the tick mark is closer to the center of the display, the spacing should be bigger, and when the tick mark is closer to the edge of the display, the spacing should be smaller. And we can do this by applying some shaping function. Let's visualize this in the online graphing tool called Desmos. So we have two axes, the Y and X, and let's for example say that the X-axis is our new value, so new position, and the Y-axis is our old position. Currently we are not doing anything with the value, meaning that the new position equals old position, meaning that the X equals Y. And usually the shaping functions works the best in the range of 0 to 1, so let's restrict our function to only go between 0 and 1, and let's zoom in a little bit more. So let's pretend that this is our display and this is the edge of the display, and around here could be the center of the display, so this will be the main tick mark being displayed in the center. So for the value of 0, the new value is also 0, so the tick mark will be drawn here. For the value of 0.1, the new value is also 0.1, the next tick mark will be here, and so on and so on. This is our boring 2D representation of our tick marks. Let's see what happens when we apply some function, for example the power function. So I'll add a new graph, new expression, and for that one let's say that the X equals Y raised to the power of 2. I will open the keyboard and select this expression, so X equals Y to the power of 2, and let's restrict the range in the same way, going from 0 to 1, and maybe even change the color from red to maybe blue. And let's again visualize our tick marks. So again, for the value of 0, the new value is again 0, but for 0.1 you can see that the new value is much smaller, so the tick mark will be around here. For the 0.2, the tick mark will be around here, and so on and so on. Around 0.4 the spacing is getting bigger, 0.5 it's even bigger, and it's growing as we move towards the center of the display. 0.7 is around here, here is the value of 0.8, 0.9, and finally value of 1 is in the middle of the display. And this is what we want to achieve with our tick marks, adding this kind of 3D look. So let's try to do this in our code. Now I'm sure that you can do all the calculations in one line of code, but I'll try to separate those into individual steps. The first step will be to convert the range to go between 0 and 1, 0 being around the edges of the display and the 1 being in the center. Then apply the power function and then convert the ranges back. I will create a new variable in the type of float, and let's call this exposition final. Inside our loop for drawing every single tick mark, I will add a new statement saying if the exposition with offset is smaller than 64. In that case, our exposition final will be the exposition with offset divided by 64. That will convert the range between 0 and 1. Then we apply the power function, so exposition final equals power of the exposition final raised to the power of 2. Actually, I think I was using like 2.5. And then we want to convert it back by saying exposition final equals exposition final times 64. If the exposition with offset is bigger than 64, now 64 should be 1 and 128 should be 0. So to convert the exposition final to a range of 0 to 1, we will say that the exposition final equals 128 minus exposition final divided by 64. Then we apply the same power function, it should be POW, and then convert it back to the range of 64 to 128 by saying exposition final equals exposition final times 64, but it should be 64 minus this value, and we should add one more 64. Once we have the exposition final calculated, I will convert it back to the integer value by rounding this value. Now before we use this exposition final to draw the tick mark, let me visualize this what's going on by drawing a second line using this exposition final, but drawing it on the bottom of the display. So for example, going from 40, I don't know, for example to 50 instead. And if I restart the simulation, I can see the 2D tick marks on the top and the 3D tick marks on the bottom of the display. And I can even draw one more line connecting those tick marks, starting on the position x position with offset, ending on the position x position final, going for example from 55 to position 38. And this is a nice visualization of what's going on, but at the same time we see a lot of lines going outside of the display, and that's because we calculate the x position with offset, but that could be outside of the display. So we should restrict the drawing by saying only if the x position with offset is bigger than 0, and at the same time if the x position with offset is smaller than 128, only in this case we will draw the tick marks. And that also helps with performance because we are not drawing tick marks which are outside of the display. I quite like this effect of those connecting lines, but I guess I will keep it for another project. For now I will use those 3D positions for our main tick marks and do some cosmetic changes. I will not draw this line, but I will copy it and paste it down here. And for the x position I will use the x position final with the same y values. Of course not to draw those two lines. Now we have only one set of tick marks. I will not draw the label for now, but I want to draw bigger tick marks for the major and minor labels. And I will do this by adding a new if statement saying if di, which is a counter used for all the tick marks, saying if there is no reminder by dividing the I by 3. In that case it will be the big tick mark, otherwise it will be the small tick mark. So this will be the small tick mark, and for the bigger tick mark, let's say the final y position to 15. And as I move those tick marks around, you can see that every third tick mark is slightly bigger. I have used Photopea to draw the image like this, the bubble image, and then export it as a PNG image by going to File, Export as PNG image, and use the image to CPP website to convert this image into the C code, first clicking the swap checkbox and then clicking the generate code and copy output, paste the image somewhere, and use the drawxbmb function to draw the image. Actually there are two images, one for the outline to cover the background with the black color, so when there is a tick mark below the bubble, there is a 1 pixel spacing between the bubble and the tick mark, and then the fill image. I think that I've also drawn the horizontal line on the top of the display like so, and then I want to draw the degree value in the center of the display, so I have to first change the color to black color for the text. Reset the orientation by going set font direction set to 0. For the font itself, I believe I've used the U8G2 font called Squeezed B7BR, and since I want to draw the label always centered, I need to know the width of the label. I can calculate it by calling the function U8G2 get string width of our string buffer, and I will store it in the new variable of the integer type called string width. And then for drawing the string, I will draw it on the x position being 64 minus the half of the width, so minus string width divided by 2, the y position being 8 because the y position is taken from the baseline of the text. Now it would be nice to show the degree symbol, but unfortunately this font doesn't include the degree symbol, but I think that we can use this apostrophe symbol to simulate the degree symbol. So inside our code, when we are converting the compass degree into the buffer string, we can not only include our integer value, but also the apostrophe symbol. And upon restarting, we have something that looks like the degree value. Let's add back those labels for the tick marks, but only for the big ones, and instead of showing degrees, let's actually show the names like S for south and for north and so on and so on. And so for that we would need an array of strings, and it should look something like this, which might be a little bit confusing because there is this asterisk which is for pointer, but you don't really have to understand this in order to use it. You just copy this into the code and then change the values, so it will be N, then it will be NE for northeast, and then east, and so on and so on. And I think that I will end with north, which is the same as the first entry, just to be sure. Then I will rename the array to be compass labels, and just copy this into clipboard because that's what we want to draw. Again, we only want to draw it for the big tick marks, so after drawing the big tick mark, I want to draw the label using the drawString function, and I want to draw the string from the compass label array, and the index should be based on I, so every third label will be drawn, so it should be I divided by 3. The Y position I believe I've set to 24, and for the X position we want this to be centered along the tick mark. So I want to again calculate the width of the string using the same string width function, so just copy this piece of code and maybe define the string width variable outside the loop function. So up here I will define the string width, which means that I don't need to define it again inside those functions, so I'll delete the integer from here and there. And then I want to calculate the string width of our compass labels with the index I divided by 3. And then finally for the X position, I will draw it on the X position final minus the half of the width of the string, which is string width divided by 2. Let's restart the simulation and see if that works. And it seems to be working, so we can see labels along those big tick marks. Now, if you want, you can also restrict the drawing only for certain x values, meaning that it will not be displayed partially on the left side or partially on the right side. So you can, for example, say only draw the label when the x is bigger than, let's say, 10 and smaller than 120. But for now, I'm interested in running this sketch on the real Arduino. Before I start the Arduino IDE, I want to see if I can change the initialization to match our real display, which is 128 by 32 pixels. So I will jump to UHG2 documentation and search for SSD 1306 128 by 32 pixels. And I'm interested in the hardware I2C connection with the letter F inside for full screen buffer. So I'll just copy this line into our code. And from the previous line, I will use, of course, the UHG2 name as well as the rotation and the reset pin being set to none. So I'll just copy and paste it like this and then try to restart the simulation. And it indeed works in the walkway. So now we are only redrawing the upper half of the display, which means that now it runs much faster. We are also using less memory, but that's not obvious from walkway because we don't see the memory usage. So now it's time to copy the code into clipboard and start the Arduino IDE. In the Arduino IDE, paste our code. Now, if you have never used the UHG2 library, you have to open the libraries, type in UHG2 and install the library. Then select the correct board, in my case that's the Arduino UNO, and hit the upload button. And in a few seconds, you should see the same sketch running on the real Arduino. The connection is the same as inside the walkway sketch, which means that for the display the ground goes to ground, the VCC goes to 5 volts, but I'm using dedicated SDA and SCL pins on the Arduino UNO board, just because those pins are closer to the display. As for the potentiometer, the middle pin, the signal pin, goes into the analog input pin A0, the other pins goes to ground and 5 volts. It doesn't quite matter which is which, but if you want to increase the value going clockwise and you are increasing the value going counterclockwise, you have to switch those pins. Now there is one thing that I haven't covered, and that's scaling of those labels. I've experimented with a lot of different approaches, but ended up using different images, like a set of images with different scale factor, and then of course drawing the corresponding image based on the X position. And while this is probably the simplest solution, it was also the fastest. In any case, if you want to play with this a little bit more, all the source files are on the GitHub, link is in the description. And that's pretty much it for today. Thank you very much for watching, and I hope to see you soon. Thanks and bye.